the lines and segments. We said that the difference between the secant and the chord, that is the chord the difference between the chords and the secant, that the chord is a line segment that started on a circle, and the other endpoint will be on a circle. So it's line on a circle. Whether the secant, it can be array, it can be a line, it can be a segment, but it starts out from the circle and end out from the circle and intersect a circle in 2 points. And then we relate here the measure of the secants and the angles. We say that if I have here two circles, one circle, and inside this circle, I have two secants that pass through. But like this, it intersects at a circle or at an angle, which we name it angle A. Now, and then the relation is the measure of angle A is, if I name this point here with angle B, a point B, here is with C, here is with D, and here is with E. Then the measure of angle A will be half the measure of the arc BC plus the measure of the arc or the length of the arc DE. Now, so here we have an example. So this is the first relation or the first formula in our lesson, that the measure of any arc that's formed by intersecting two secants is half the measure of the arc BC plus the measure of the arc DE. So let's repeat it here, that if I wanted to find the measure of angle A, this angle A now, it comes because of intersecting two secants. These two secants are BD and CE. The opposite angles, the two vertical arcs that are opposite to the angle A are BC and DE. And we explained at morning why they are half of them. Now, so the measure of angle A will be, I will add the measure of the arc BC plus the measure of an arc DE, then divided by 2. In this case, I'll find the measure of angle A. So here now, let's have this example here. If I have a circle, and for this circle, I have two secants that are intersecting at a circle, but not on a center of a circle. Given that here I have an A, here I have D, here I have B, and here I have C. And here I have angle 1. Now, how can I find the measure of angle 1? It's half of what? Which R's can I use?
AD and BC.
AD and BC. So 155 plus 61. Half of it will be 155 plus 61 is 116 divided by 2, which is 108. So the measure of angle 1 will be 108. So next now. So In the theorem 1010, we said that if the two secants are intersected inside a circle, the measure of the angle will be half the sum of the two arcs. But if the two secants now are intersected outside the circle, as is shown in case 1, case 2, and case 3, if they are intersected outside the circle, okay, so the width will be half the difference of the arcs. So remember, if they are intersected inside a circle, it will be half the sum of the measures of the arc. But if the two secants are intersected outside the circle, it will be half the difference of the measures. So now let's connect the words. Inside, I will add. Outside, I will subtract. Here now I have three cases. What's the difference between the three cases? Let's see now case number 1. In case number 1 here, as you see, I have two secants that are intersected outside the circle. So if the measure or if the length of the measure of the arc here is B and here is A, so the measure of the angle will be half the difference of B minus A. The second case, if the angle now is formed by intersecting a tangent line with a secant with tangent, when they are intersected at an angle which they are outside the circle, so it will be half d minus t. And the third case, if the two tangents now are intersected outside the circle, so that forms two arcs F and E, so the measure of angle 3 will be half F minus E. So here the three cases are, first of all, remember if they are intersected outside, I should subtract. The three cases, case number 1, the angle 1 is outside the circle and it's formed because of intersecting two secants. Angle 2, it's outside the circle and it's formed because of intersecting a secant with a tangent. And the case 3, I have two tangents line, they are intersecting outside the circle, so the measure of angle 3 will be the difference of the two arcs. This is clear? Agatha?
Yes.
Okay. Right, now, here now let's find the
Teacher,
measure.
teacher, why in the first theorem, why is it not half? Why do we need to minus A from B?
It's half
Yeah, half, but we need to minus A from B.
because
Why?
the intersection outside the circle.
Okay.
Okay, but if the intersection inside, I will add.
Thank you.
Fine. Here now, here now I need to find the measure of an angle ABD. Fine. So here I have ABD. Where is an angle ABD? Is it outside or inside?
Out.
Outside. So to find the measure of an angle, ABD, it's equal to what?
Half.
It's equal to half the two arcs that comes between their hands. And if you look at the angle ABD, it has two hands. These two hands, beside it, we have two arcs. The first arc is AD, and the second arc is AC. Okay, I'll repeat. Here I have the two hands for the angle. Which are they? They are BD and AB. Now, between the hands of the arc, of the angles, I have two arcs. What are these two arcs?
AD
First
and
one
AC.
is AD. Sorry. It's an AD. And the second one, it's an AC. So it seems to me now that I will say that the measure of the angle ABD is half the greater one, which is, or the bigger one, which is 151. Now, is it minus or plus?
Minus.
Minus. The measure of an arc AC. And the measure of an arc AC here now is unknown. Done. How can I find the measure of AC?
We add 139 or
Excellent.
51
Excellent.
minus
Yeah.
10.
So here from C to D, it's 139. From D to A, it's 151. So AC, in order to find an arc AC, I should subtract 360 minus 151 minus 139. So the answer is
70.
70. So now here, the measure of an arc is 70. So it comes with me now as an half of 151 minus 70, which is equal
81.
81. Divide by 2. So what's the measure
40.
of the angle? 40.5. So the measure now of the angle ABD is 40.5. Is it clear?
Yes.
Okay.
Yes.
Now next. Now, what is the measure of an arc LM? Can this one keep it later? Let's solve this one first. Let's start with the easier. Yeah, here number 3A. I need to find the measure of an arc WX. So what's the given here? The given is an angle and one of the arc. And they asked me to find the arc WX. How should I start? I am Ali. How can I start here?
Teacher, wait, can you go back to the previous thing that you showed?
Okay. This one?
No, no, the other.
The one that has X?
Yes, teacher, Hon,
Oh.
do we do only the half like of LM, the arc LM equal angle J?
See, no, this one I will show it to you, but I need to solve the easier first. Hello, we said that half of the difference of the arcs equals the angle. So double of the angle equal to difference of the arcs. So I will do algebra. I will subtract 6x plus 6 minus 3x minus 5 equals double of the angle, which is what? 68. So I can find x. Got that?
Then when do we do only half without plus or minus?
If the angle, okay, I will do half without plus or minus if the angle now is intercepted angle. I mean, like its vertex is on a circle.
Okay.
Okay,
Thank you.
but the second case, this case, they are outside. The previous case, the one that I explained at morning, which I have. Sorry, just a minute. If I have now two secants that are intersecting inside, so the measure of this angle will be the difference of the two arcs.
Okay, thank you.
You are welcome. So here, let's summarize now. If in the 4 cases that we talk in our up to now, that the first case, if the two angles Oh, the angles are in a center of a circle. So in this case, the measure of the angle equals to what? The measure of the arc, which is the central angle. The second case, if I have an comes between two chords, it forms an angle now. This measure of the intercepted angle or intercepted angle here equals to what? To the measure half of the measure of the arc. So if the angle now is n on the center, it's equal to the measure of the arc. If it is its vertex is on any point on a circle, it's half the measure of the arc. If I have now the angle, it comes because of intersecting two secants now. This one will be half the difference of the first arc minus the second arc. If the angle now is outside, it forms like this as an example. So I will subtract the first arc minus the second one. Is it clear? Return.
Yes, thank you, teacher.
Okay.
Yes, miss.
Let's continue here. Now this one, I'll come back to it, don't worry. But let's first solve the easier one. Yalla, so let's go now back to number 3a. Here I have the measure of an angle is 107. One of the arcs, which is YZ, is 74. And I ask you to find the measure of an arc WX. Let's know that the ratio that we have it before. The measure of the angle 107 equals to what? Half
of
W
Y
of
and W
74 plus
Half of
add
47
WX.
minus.
Excellent. So half of, not minus, here is a plus because it's inside. Okay, Mary? So here now 107 of half WX plus the 74. So now let's multiply 2 by both sides. So 107 times 2 is 214 equals to 74 plus WX. This WX, I mean arc, okay? This one here means an arc, WX. So then minus 74 on both sides. So what's the measure of an arc WX?
140.
140. Is it clear?
Yes, thank
Right.
you.
In B now, I need to find the measure of an angle PSQ. Type PSQ, is it inside or outside the circle?
outside.
Outside.
Outside. Thank you, Saf. I need to find the measure of an angle that is outside the circle. I need to what? To add or subtract?
Minus.
Minus
Type. Which
152.
100. So it's half of
Of
152 minus what?
152 minus PR.
Minus PR. Excellent. An arc PR. Type. Now, half. So
Arc PR.
half of 152. But how can I find the measure of an arc PR?
360 minus 152 plus
Excellent.
126.
360 minus 126 minus 152, which gives me 82.
82.
Yes. Then 152 minus 82. So what's the measure of an angle will be now?
35.
35, thank you. So here, in order to, why I found it? Because here, if you didn't understand, here I need this arc, PQ and PR. This one, I don't need it. How will I find it now? I will subtract 360 minus 152 minus 126. Is it clear?
Yes.
Yes.
Right. Now, for exercise 5 and 6, find each angle measure. Raise QP and QR are tangent to the circle. Now here, I need to find the measure of BEC. Let's choose Hannah.
Yes, Miss.
Yes, Hannah. Just a minute, first. Here now, how can I find the measure of an arc BEC? The angle, sorry, BEC.
Half arc BC,
Half of arc BC, which is
86.
minus sorry, minus or plus? I'm sorry. Plus what?
Miss White,
So here. So here now, it's half BC, plus or minus?
plus because it's inside.
Plus because inside. Bravo. Plus what? Plus the second arc, which is 60. So then let's add 86 plus 60 divided by 2. So what's the measure of an arc BC? The angle BEC, sorry. It will be 73. Now next, and number 6 here. They ask you to find the measure of the angle, given that the measure of PR is 125. Okay? So yeah, Yasmin, how can I find the measure of PQR here?
Half
So
piece
measure of PQR is half
half
of what?
piece
PSR. Excellent. Arc. PSR minus arc what?
PR. PR.
PR. Thank you. Now then, so half times. Now the arc PSR, what is its measure? Oh, think, sorry.
360 minus 125,
Excellent. It's 360.
which is 235.
235 minus arc
Minus
PR. Bravo. So what the answer of the angle, or the measure of the angle, sorry, will be
55.
55. Thank you. Is it clear?
Yes.
Let's go back now to B here. And B, what do I have? I have the measure of an angle J, which is 34. I have the length of LM, but given now as algebra, as an expression, 6x plus 6, and the length of Kn, it's 3x minus 5. Now, we said, to solve it here, we said that the measure of the angle is half the measure of the difference of the two arcs because it's outside, which means 6x plus 6 here minus what? Minus the 3x minus 5. So here it's the difference of the measure of the two arcs. Now then, multiply by 2 on both sides. So what do you get here? 68 equals to 6x plus 6 minus 3x. I will distribute the minus plus 5. Then 68 equals to 6x minus 3x is 3x
3x plus
plus
1
6 plus 5
plus 1.
plus 11. Here I have positive 6, and here I have negative by negative 5, which is positive 5. So now then, minus 11 on both sides. What do I get?
57.
57 equals
Then
to
divide by 3.
3x. So x will be
19.
19. Excellent. I found 9x now. What the question asked me to find? The measure of an arc, LM. So how can I find the measure of an arc, LM?
6 times
I will replace.
19
So it's a 6 times 19 plus 6,
plus 6.
which is
120.
Fine. Now here, the measure of angle 1. The same idea. How can I find the measure of angle 1 here?
Half
80 plus 106.
Bravo. Half. So the measure of angle 1 is half of 106 minus, plus 80, which is
93.
93. Thank you. Here now, how can I find x?
half
Half of what?
81 equal half
أيوة 81 equals half
122.
122
plus 122.
plus x
plus x. Thank you. Then divide by 2, multiply by 2, sorry, on both sides. So what do you get?
9.
162 equals to 122 plus x.
122 plus x.
Then x will be
40.
40.
40. Thank you. Now, I give you the idea of example 4. So start with it. Inshallah, tomorrow I will repeat it for you. Now, here, if I have, in this example now, I will show you how we find the length of the chord. What do I mean? If I have here a circle, And here I have inside the circle, I have two chords like this. Then I ask you to find the measure or the length of the chord. Given that this one is 5 as an example, or 4, this one is 5, this one is 7. I ask you to find the measure of this segment. How can I find it? How can I find the length of these sides? Now, there have 3 cases. I will explain it to you each case by one, but let's start with the first case where if I have now the two chords are intersected inside a circle, how can I find the length of these two chords? Now, first case here, let's start now with let's draw 2 lines. This is the first one, and here is the second one. I need to find the measure of this arc. Okay, given that here is 4, sorry, I deleted my mistake. Here is 5. Here is 6 as an example. And this segment here is X. What I will do now, first of all, let's draw now 2 segments. That's when they close them and make like 2 triangles. Now, using a similarity, if I have here A, and here is B, and here is C. And here is D, and here is E. Now, how can I prove that angle, triangle A, yes?
Teacher, here do you mean by like similar triangles have congruent angles? Or are the triangles equal to each other?
So here, yeah, I need to prove the similarity first. Okay, I have a triangle ABC and triangle CDE.
Angle C and angle C are congruent because they're vertical angles.
Excellent. So I need to prove it by similarity. You know that the 3 theorems are AA or SAS or SSS. As you said, one of them is the angle, which is angle C, and both sides are equal because of the vertical angles. Now, what are the second 2 angles? Oh, the second angle, sorry.
Teacher, is C the center of the circle or no?
No. It's not on the center. The center, say that the center is here. It's another point. Here is the center. Did you remember now first of all, if I ask you now, what is the measure of an arc A? Arc A. It's half of what? Of the angle A, sorry, which is half of BE. Or angle D, it's half of BE.
So they're equal.
Yes, they are equal. So we said before, if they are 2 inscribed angles, they share the same arc, so they are equal. So angle A here and angle D are equal. Or this angle and this angle here are equal also because of the vertical angles. So I can conclude now that triangle ACB is similar to CDE by AA similarity. Is it clear?
Miss,
Can
can
you
you
repeat?
after you said that A and D are
Okay.
equal?
Okay, here now I have this triangle and this triangle. So this angle here, angle A and angle A are equal because they are vertical angles. And angle A here and angle D here are equal because they share the same arc. So the two triangles, which is A, B, C, is similar to D, C, E because of AA similarity. Did you remember this one? EA. Oh,
Yes, yes,
I don't know what's the, wow. The similarity, you know the sign.
yes.
Right. So here now,
Teacher, but shouldn't it be like AAA, not two angles only?
Miss, there's no AAA. Why? Because the third A will be equal by default. I mean, like as a numbers here. If this one is, imagine now this angle, the angle here is 30. And
Teacher,
this
خلاص
angle,
I understood.
yeah.
I understood.
Okay, imagine that if the 30, and here is 70, and here is 70. So the third one will be what? The first case, 80. And here,
And then the second one, it
one
will
will
be
be 80.
82.
So no need to prove 3 angles. Just 2 angles, at least 2 angles will be enough.
Okay, thank you.
Okay. So now the two triangles A, B, C and C, D, E are similar by AA. طب did you remember now the similarity ratios? If they are similar, can I say that 6? Oh, sorry. That
6 over x
أيوة 6 over x
equal
equals
4
what?
over 5.
4
4
over
over
5. I'm sorry, and the Zoom is less than 1 minute, so may it finish at any time. So if you multiply cross multiplication here, it's 6 times 5, 30, divide by 4, which is 7.5. This is how to find x here. Is it clear?
Yes.
هلا this way here is a proof how we